This topic will be about Riemann sums. Riemann sums are considered an approximation. It's a mathematical use. It was created by the mathematician Bernhard Riemann, who was a German. It is mostly applied in the approximation of areas of functions, lines, or graphs. It is also calculated by dividing a region into shapes, such as a rectangle, a square, a semicircle, or any other shape, geometrical shape. The whole point is to find a numerical approximation for a definite integral. Riemann sums will be dividing the area more and more to make areas more accurate each time. In this example, we can observe how they are giving us two x's and a delta x. The first is x1, and we're gonna have a delta x of 0.5, which is we are going to be dividing each one by 0.5, I'm sorry. By dividing this, we are gonna apply the Riemann sums, and we're gonna be making a kind of bar graph in which we are going to reduce the size so we can get the area of this rectangle. We're gonna have this area, and the missing parts are gonna be this small part here. This is why it is considered an approximation, because it is not accurate. Here is another example. We have this function, x to the second. We're gonna have our x's, x1 and x5. We're gonna plot the x's here. Then we're gonna put our x values in the function, which is here. We're gonna have a 1, 4, a 9, and a 16. This will be only for the left area. We have a delta x of 1.5, which is why we are going to be multiplying each y value by delta x, which is 1.5. We're gonna obtain our values and the area here. We're gonna do the same with the right area, but now since it's the right, we're gonna begin with the 5. We begin with the 5 and we plot our x values. We do the same, we plot them in the equation. Here we're gonna have a 25, a 16, a 9, and a 4. Once we obtain our x values, all of this, we are gonna multiply the same times the dx, which is this one. Once we multiply our values, we're gonna have a total, and when we add them, we're gonna get the area of the right. And whenever we have our values, that's gonna be our answer. In this case, it's a little bit more complex since our function it's a little bit more complicated, but it's the same case. You have x, you have your both x's, and you have your dx, which is the difference. You put your x values beginning in the left from 0, 1, 2, and 2.5, since we cannot plot. Okay, well, let's put a 3. On the right values is gonna be the same, but we begin with a 12 and we go downwards. Sorry. You have, after that, you put your x values in your equation. This will give us a 4, and this will give us a 5, 8 plus 4, 12, and like that. It's gonna be the same case. Our y value, we multiply it by dx, which in this case will be 12. plus now the 5 multiplied by 3